Welcome to This Explainer. Today, we are diving deep into a topic that is absolutely crucial for your Cambridge Physics 0625 syllabus, the magnetic force on a current. But we're not just going to read textbook definitions. No, we are taking an application-first strategic approach. Think of this as your masterclass in exam strategy. Look, every year, thousands of students walk into their physics exams confident, only to get absolutely crushed by structured questions on this exact topic. Why? Because they ignore the warning signs. They fall into the same traps. Take two hypothetical students. Let's call them Alex and Sam. Now, Alex is the classic overpreparer. When faced with a question about a wire and a magnetic field, Alex overloads the page with raw physics facts. Paragraphs of text defining every term under the sun, but absolutely zero real analysis. On the other hand, you have Sam. Sam rushes. Sam reads a complex four-mark question, writes down one quick, fragmented sentence, and completely misses the command word requirements. Both of them walk out feeling okay, but when results day comes, red pen marks everywhere. Their grades sink. Today, we are going to fix that. We are going to decode exactly how this physics appears in real systems, in your calculations, and in those tricky structured questions, so you never have to guess what the examiner is looking for. So let's start with a foundational question, and I really want you to stop and think about this for a second. What physical effect, measurement, or prediction actually depends on understanding the magnetic force on a current? Why do we even care about this? We usually start this topic by memorizing a rule, right? Like Fleming's left-hand rule. You contort your fingers in the exam hall, hoping you're pointing them in the right direction. But understanding exactly why this physics is needed in the real world completely breaks our reliance on rote learning. We aren't just memorizing hand tricks, we are predicting motion. We are predicting how an electrical input translates into a mechanical, physical output. When you understand the actual real-world purpose of this phenomenon, it's like a superpower. It helps you logically reason your way through completely unfamiliar exam setups. The examiner could throw a totally bizarre diagram at you, a weirdly shaped magnet, a strange circuit, and instead of panicking or just guessing, you'll know exactly how to break it down. You'll recognize the underlying pattern because you understand the core physical effect. Section 1. The four-step exam framework, decoding IGCSE physics requirements. Okay, let's get into the mechanics of a perfect answer. Top-tier exam answers, the ones that get full marks effortlessly, don't just regurgitate isolated facts. They follow a highly logical, structured sequence. We call this the DREA framework, and it perfectly maps to the required physics assessment objectives. First, step 1, you identify the phenomenon. For example, if you see a wire moving when placed in a magnetic field, you name it, that's the motor effect. Step 2. State the relationship. You need to explicitly say that an electrical current interacting with a magnetic field creates a resultant force. Step 3. Explain the underlying physics. This is where most students drop marks. You have to explain how those two magnetic fields interact with one another. The field from the permanent magnet and the field generated by the current in the wire. And step 4, connect it to a real device, like a DC motor spinning. Keep these 4 steps locked in your mind, because this logical sequence proves to examiners that you have both the theoretical depth and the practical application down. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, getting back to it. This DREA framework is essentially your safety net. Whenever you see a high-value question, mentally tick off these 4 boxes. Section 2. Cause and effect physics, from everyday words to physics vocabulary. To really master Cambridge physics, you must insist on cause and effect rather than just listing isolated facts. Think about how a top student structures their answers. A really strong grasp of physics gradually shifts from concrete, everyday examples to highly precise symbolic relationships. You have to upgrade your vocabulary. For instance, imagine an exam question where a wire jumps between 2 strong magnets when the switch is closed. The everyday way to describe that is just the wire moved because the power turned on. But examiners don't just want to hear the wire moved. That gets you maybe 1 mark if you're lucky. They are actively hunting for the cause and effect chain. So, how do we transform that answer? Like this. The electrical current flowing through the wire created its own temporary magnetic field. That's the cause. Then, this new magnetic field interacted with the permanent magnetic field from the magnets. That's the mechanism, resulting in a resultant force that pushed the wire. That's the effect. Cause, mechanism, effect. Every single time you write an answer about fields, forces, or circuits, ask yourself, did I clearly explain the cause and effect chain? Section 3. Beating common exam pitfalls. The exam lens. Now, please pay very close attention here because we are going to look through the examiner's lens. These are the 3 most common traps that will instantly sink your grade when answering questions on the magnetic force. Remember our hypothetical students Alex and Sam? This is exactly where they mess up. First pitfall, writing a correct formula without explaining the variables. Alex loves doing this. Alex will just write F equals BIL right in the middle of a paragraph. Sure, the formula for magnetic force is force equals magnetic flux density times current times length. But in a descriptive question, dropping a naked formula gets you nowhere. You have to explain what those variables actually mean in the context of the specific system you're analyzing. Second pitfall, quoting a process without linking it to a physical effect. Sam does this constantly. Sam will write, "The magnetic fields interact." Okay, great. But what is the physical effect of that interaction? You have to finish the thought, which creates a resultant force that causes the wire to accelerate upwards. And the third major pitfall, dropping a real-world example without showing exactly why the physics makes it happen. The examiner doesn't want to know that you've just memorized a list of devices. They want proof of the mechanics. They want to see that you understand how the system actually operates under the hood.
So, how do we transform these weak answers into perfect scores? Instead of taking a weak rote memorization approach, like dropping an isolated formula with 0 context on the left side of your mental balance sheet, you need to utilize the ultimate blueprint for maximum points. We call it the SAFE method, which relies directly on that DREA framework we talked about earlier. Definition, relationship, explanation, application. DREA. If you structure your exam answers using this exact method, you ensure that every single microtopic is tightly connected to clear, undeniable reasoning. You start by defining the core idea. Then you state the equation or the proportional relationship. Next, you explain that crucial cause and effect chain. And finally, you apply it to a practical use. When you practice writing your answers like this, those red pen marks transform into green check marks. It is a completely foolproof way to secure those top marks because you are systematically hitting every single point on the examiner's mark scheme. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Real-life system applications. Why this physics matters outside the classroom. All right, let's step into an interactive workshop mindset for a moment. To prove true, deep comprehension to an examiner, you must always be able to name real situations where this concept actually matters. The magnetic force on a current isn't just some abstract diagram in a textbook. It is literally the absolute foundation of modern engineering. Let's do a quick mental challenge. Think about transport systems, specifically maglev trains. If an exam question asks you to explain how a maglev train works using the magnetic force on a current, how would you answer it? Set a mental 60-second timer right now. Could you extract the core physics trend? You'd need to explain that these powerfully interacting magnetic fields are used to physically lift the train, literally floating it above the tracks, completely eliminating mechanical friction. What about medical technology? Think about advanced MRI scanners, or massive energy grids and global communication systems. These aren't just trivia facts. Your goal should be to pick just 1 or 2 of these specific fields and memorize exactly how the physics, the interaction of a current-carrying conductor and a magnetic field applies to it. When you can seamlessly weave a real-world application into your explanation, it shows the examiner you aren't just reciting a textbook. You actually see the big picture. You understand the profound impact of the physics. Section 5. The revision climax, securing your exam knowledge. We are reaching the culmination of our strategy session. I want to present you with a complete physics answering system. If you want to guarantee top marks, you need rules. Rule 1. Command word decoding. Always know if you're being asked to state, describe, or explain. Rule 2. Framework application, using our DREA method. And Rule 3. A time management matrix, making sure you don't spend 10 minutes on a 2-mark question. To anchor all of this, here are 4 essential memory prompts. Think of these as your ultimate revision cheat sheet for this topic. Whenever you finish studying the magnetic force on a current, you need to sit back, look away from your notes, and ask yourself these 4 questions. Number 1. What is the core idea? Number 2. What changes physically in the system? Number 3. What specific quantity, formula, or graph actually shows this change? And number 4. Where is it used in the real world? Systematically testing yourself with these exact prompts ensures your knowledge is absolutely secure.
It forces you to actively recall the information, which builds the exact neural pathways you'll need when you're sitting in that quiet exam hall. So, I am going to leave you with a final provocative challenge. Can you answer those 4 memory prompts aloud right now for the magnetic force on a current? Seriously, don't just nod along in your head, actually try to speak the answers out loud to the room. If you can effortlessly talk through the core idea, the physical change, the mathematical relationship, and a real-world application, then you are ready. You have mastered this module. But if you hesitate, if you stumble on the physical changes or forget the application, then you know exactly where the gaps in your knowledge are and you know exactly where to start your revision today. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.